Salam and peace be upon you all. My name is Mohammed Layiq Sediqi, the father of Holophase. Welcome to episode 5, part 9. Let's give this part a very honest title in plain language. How to kill Holophase if it's wrong. Because if this model cannot in principle be broken by reality, it does not deserve to sit at the same table as Newton, Maxwell, or Einstein. In this part of episode 5, you and I are going to do something unusual for a big theory of everything. We are going to walk carefully, step by step, through how you would attack it. Not with vague, it's consistent with everything hand-waving, but with clear tests in everyday language. Tests sharp enough that a serious physicist cannot wriggle past them, and simple enough that you could explain them to a smart teenager. By the end of this part, if Holophase still feels interesting to you, it should not be because it sounds mystical or poetic. It will be because it has done something rare. It has told you exactly how reality could prove it wrong. 1. What exactly is on the line? First, let's be very clear about what we are putting at risk. Holophase is not just saying phase is useful in physics. We already know that from waves, optics, and quantum mechanics. It is making a much stronger claim, which we can compress into 3 sentences. First, there is a single underlying phase field, phi, spread through the parts of the universe where physics works. Second, what we call time, space, and motion are not 3 separate substances. There are 3 different ways of reading how phi changes. Time is how fast phi ticks along your path, its local cadence. Space is how phi differs from place to place, its gradients and curvature. Motion is how recognizable features of phi drift through that pattern, its flows. Third, the familiar laws of physics, from Newton's mechanics to quantum theory to relativity, are not separate commandments written on the sky. There are grammar rules about how phi and its derivatives are allowed to evolve while keeping those 3 echoes consistent. We can hang this above the lab bench in one line. Wherever time, space, and motion are doing reliable work for physics, there must exist a consistent description in terms of one phase field, phi, and its derivatives. If there isn't, Holophase is wrong. Now we are going to build a set of tests, falsification gates, that push directly on that line. Each gate says, in one way or another, if the world ever behaves like this, then time, space, and motion cannot all be shadows of a single phi. And the Holophase story, in this strong form, collapses. We begin in the most concrete place, the instruments in your hand. 2. Gate 1. The instrument triangle. Clocks, rulers, speedometers. Holophase makes a very simple claim about measurement. Every clock is deep down a phase counter. Every ruler is a phase difference probe. Every speedometer is a phase drift meter. Strip away the casing and the branding, and the skeleton is always the same. Something repeats, a swing, a vibration, a transition. You count or compare those cycles. You call the result time, distance, or speed. An atomic clock counts oscillations of an electronic transition. A laser rangefinder compares the phase of a bounced wave. GPS is a choreography of synchronized, phase-coded signals. Holophase says, this is not a technological accident. It is a fingerprint of how reality is built. Whenever you measure time, space, or motion with real precision, you are, somewhere in the chain, reading the behavior of a phase field. So gate 1 is the instrument triangle test. Can you build, or even imagine, in principle, a stable, precise measurement of time, distance, or velocity, whose entire operation does not depend on any repeating process, any oscillation, any wave-like structure anywhere in the chain. Imagine someone shows you a clock that keeps time with no cyclical process at all, a ruler that establishes length without any reference to repeating structure, wavelength, or propagation, a speedometer that measures velocity without tracking the drift of some pattern over ticks. And you can describe the full operation of the device without ever smuggling in phase-like behavior under a different name. If that really exists, the holophase picture takes a direct hit. Because then we would have a working notion of time or space or motion that does not lean on rhythm at all. That would mean time, space, and motion are not necessarily phase echoes. At least some of them can stand on their own. Right now, every ultra-precise instrument we actually use, atomic clocks, interferometers, radar, metrology standards, is built on oscillations and phases. Gate 1 turns that fact into a challenge. Try to escape the triangle. If you can really measure without any hidden rhythm, the dimensional story of holophase is in trouble. 3. Gate 2. Phase windows. Can you have law without phi? The second gate goes a level deeper, into the idea of a phase window. Holophase insists on working with finite, licensed windows, patches of space and time where behavior is orderly enough that you can honestly talk about phase. Regions where you can, in principle, reconstruct a phi pattern from what you measure. Think of a simple optical experiment. You send light through a pair of slits. On the screen, you see bright and dark stripes. We already know how to explain this. At each point, the light wave has some phase. Where phases line up, you get bright bands. Where they oppose, you get dark bands. There is a phase window. In that patch of reality, you can meaningfully assign phi values and recover the pattern. Holophase says, whenever physics is precise and repeatable enough to talk about time, space, and motion in some region, there must exist at least one phi window on that region, some way, in principle, to represent what is happening as a configuration of phase and its derivatives. So gate 2 is the phase window test. Find a domain of phenomena where time, space, and motion are used successfully, where we have clean predictive laws, but where there is no possible way, even in principle, to construct a consistent phase description on any finite window. No phi map whose interference, gradients, and flows reproduce the behavior. Not just difficult, actually impossible without contradiction. If such a domain exists, holophase cannot claim that phi underlies all dimensional behavior. We can sharpen this further. Whenever we see patterns that look like interference, fringes, oscillations, patterns that are sometimes strong and sometimes vanished, we should be able to assign a set of phase values whose combinations explain those patterns. If you can find a reproducible interference-like phenomenon that defies every possible phase assignment, where no phi map explains the data without breaking somewhere else, holophase loses one of its loudest voices. Interference is how phase shouts. If we ever find interference without any possible phase, physics is saying, I can do this trick without your phi. So gate 2, in full strength, says, if there is a region where laws work, dimensions are in play, patterns look wave-like, and yet no consistent phase window can be built, then holophase's claim to be a universal substrate is false. 4. Gate 3. Lockstep deformation. Can one dimension wander off alone? In episode 5, we introduced a strong idea. If time, space, and motion are three projections of one underlying rhythm, then you cannot deform one projection without, somewhere, tugging on the others. Imagine a hand casting three shadows on three walls. One shadow is labeled time, one space, one motion. When the hand moves, all three shadows must respond. You do not get to wiggle the time shadow while the other two stay frozen, because they all come from the same object. Holophase says reality works like that. If something changes the local behavior of phi, the way clocks tick, the way distances are measured, the way patterns move, then all three echoes must be affected in a structured, coupled way. Relativity already hints at this. Move fast, and both your time and length measurements change. Sit near a massive object, and both your clock rate and your sense of distance warp. So gate 3 is the lockstep deformation test. Find a regime where one dimension, time, space, or motion, can be systematically altered, while the others remain completely untouched in all experiments, and cannot be forced into coherence with a single change in phi. For example, imagine a future experiment that slows down all clock-like processes in a region, nuclear, atomic, mechanical, biological, but distances and wave behaviors remain perfectly normal. Motion patterns show no linked change, and no phi story can explain both what changed and what did not. Or imagine the reverse. Space is stretched in a way that affects distance measurements, but all local clock rates and motion behaviors remain exactly as before, and every attempt to describe the whole situation as a single phase deformation fails. If such orphan deformations exist, time drifting without consequences for space or motion, or space deforming with no cost to clocks or flows, then the idea that all three are just echoes of the same phase field breaks. In one line, if the universe can reliably bend one leg of the dimensional tripod without forcing anything onto the other two, then they are not three shadows of one object, and holophase fails. 5. Gate 4. Cross-scale consistency. Does the phase story survive every zoom? One of the boldest parts of holophase is its scale claim. We have said, at quantum scales, phi is a rapid, flickering rhythm. At human scales, phi settles into mid-band patterns, sound waves, vibrations, chemical oscillations, neural rhythms. At cosmic scales, phi stretches into slow, deep patterns, orbits, spiral arms, cosmological flows. We use the analogy of one piece of music played at different speeds. Very fast, it becomes a buzz. At normal tempo, it becomes a melody. Very slow, it becomes chords that change over hours. Different experiences, same score. Holophase claims, from quanta to galaxies, all lawful patterns in time, space, and motion are different tempo bands of one underlying phase code. So gate 4 is the cross-scale consistency test. Take three very different scales: a quantum system, like electrons showing interference, a mesoscopic system, like waves on a membrane or patterns in a fluid, and a cosmic system, like orbits or large-scale structure. Ask, can we, at least in principle, tell a single phase story that spans all three, where each effective law at each scale is a coarse-grained sentence in the same phi grammar? Holophase does not demand one neat equation to cover everything. It demands something deeper, that we never have to say, at this scale, reality stops being wave-like in any meaningful sense and becomes something fundamentally different. If we discover a scale where time, space, and motion are used successfully, where we have precise predictive laws, but where no phase-based description works, even with creative coarse graining, then the scale ladder breaks. That would mean, here is a patch of reality where dimensions behave well, but no phi story can live underneath them. And holophase, as a universal ontology, is finished. 6. Gate 5. No orphan laws. Can any law refuse phase? Holophase makes another sharp claim. Any genuine law of physics that talks about time, space, or motion must be expressible as a constraint on phi and its derivatives. In other words, If an equation uses time, position, velocity, acceleration, distances, durations, or trajectories, Holophase says there exists a phi-based version of this law, where those quantities are readouts of phase cadence, gradients, and flows. So gate 5 is the no orphan laws test. Find the core, well-confirmed law of nature, not a temporary model, but a trusted structural law that fundamentally depends on time, space, or motion, and yet cannot be rewritten, even in principle, as a rule on a phase field and its derivatives without losing its predictive power or internal consistency. To genuinely break holophase here, you would need to show that every attempt to cast this law in phase grammar leads to contradictions or wrong predictions, while the original, non-phase form remains beautifully correct. That would be an orphan law, a law that insists on living directly in time-space motion language, with no phi translation possible. If we ever found such a law, holophase might still be a powerful framework for many domains, but it would no longer be allowed to pretend to be the foundation. If phase is really the substrate, no dimensional law is allowed to say, I do not speak that language. One orphan law is enough to break the spell. The 7. Gate 6. Coherence and noise. Can sharp structure arise from phase chaos? Another key ingredient in holophase is coherence. To talk meaningfully about phase in some window, phi there has to be coherent enough. If phase is completely random from point to point, you cannot assign a clean phi. You just get noise. We already know this from optics. A laser with high coherence gives sharp fringes and crisp interference. A light bulb with random phases gives a blurry smear. Holophase turns this into a general principle. Wherever you see sharp, stable, repeatable structure in time, space, or motion, especially wave-like or interference-like structure, there must be underlying phase coherence in that window. So we get two linked tests. The coherence gate says, if you can prove that in some region phi or any candidate phase field is truly incoherent, no usable phase relationships at all, and yet that region produces sharp, stable, interference-like patterns, holophase's coherence-first view is wrong. The linked noise test says, if everything is phase at root, then certain kinds of noise in time, space, and motion should be related. Temporal jitter, spatial blur, and motion noise should have a phase-based relationship. If precise experiments repeatedly show these noise patterns to be completely independent in regimes where holophase would expect linkage, that is another wound. In human terms, people clapping in perfect sync can create complex rhythms. People clapping at random create mush. If we walked into a theater where people were provably clapping at random, and yet a stable, intricate rhythm emerged and held, we would know our rhythm needs coherence story is missing something big. Gate 6 asks the universe, do sharp patterns always ride on some kind of hidden phase alignment, or can reality conjure crystal clear structure out of pure phase chaos? If the second is ever shown clearly and cleanly, holophase loses a key internal pillar. 8. Gate 7. Extra ingredients and mind. Can anything important escape phi? Up to now, our tests have stayed inside classic physics territory. Now we touch two edge domains. First, extra ontological ingredients. Holophase says, at the level we are talking about, we do not need to posit any ontic stuff beyond phase order and its derivatives. Energy, mass, charge, even geometry are derived tallies and patterns in phi, not rival substances. So we have the extra ingredient test. If future physics is forced by clean experiment to introduce some new irreducible ingredient that cannot be represented as phase structure of any kind, holophase is incomplete. For example, if some new sector of reality behaves in ways that resist all attempts at phase-based modeling, not just technically, but in principle, then phi cannot be the whole story. Second, mind and meaning. Holophase refuses the easy way out of saying consciousness is an illusion. It says instead, whatever consciousness is, it must be expressible, at least in principle, as organized patterns of phase in some substrate. So we have the mind escape test. If there are aspects of experience or cognition that make systematic, reproducible differences in the physical world, and yet cannot be, even in principle, encoded as patterns and dynamics of a phase field, then holophase fails as a complete ontology. In plainer language, if some part of mind shows up as causal, it pushes the physical world. But that push cannot be traced to any phi pattern anywhere, then something is happening outside the phase story. Holophase can live with mystery. It cannot live with causal ghosts that refuse any phase representation. If we are truly forced to add a new base ingredient, some stuff or some mind that cannot be written in phi, then holophase has overclaimed. It might still be a powerful layer, but not the base layer. 9. Gate 8. Phase-first predictions and edge regimes. Up to now, most of our gates have sounded like, if you ever see this, holophase dies. A fair skeptic might say, good, but where does holophase predict anything? Where does it stick its neck out and say, this must happen or this can never happen? Starting from phi as primitive, holophase can, in principle, generate phase-first predictions such as specific coherence thresholds where our usual time-space motion descriptions should begin to fail, specific linked noise signatures across clocks, rulers, and motion sensors, specific forbidden combinations of behavior that are illegal in phase grammar. These mostly belong to the technical work, but the structure of the bet is clear. There must be patterns which a phase-first ontology says. You will see this kind of coupling if you look carefully enough. You will not see this kind of behavior in any stable system. Add to this the edge consistency test. In the most extreme regimes we can probe, near light speed, near strong gravity, in delicate quantum interference, in exotic phases of matter, holophase must be able to give a coherent phi description of what is going on, and ideally offer a clearer way to phrase subtle predictions. If those phi descriptions repeatedly fail where our existing formalisms succeed, holophase is not the upgrade it claims to be. Think of these as frontier bets. In messy, extreme situations where our current languages are stretched thin, does a phase-first language help, and does it keep agreeing with experiment? Or does it break, while other ontologies keep standing? If it breaks, we have learned something honest. Phase is powerful, but not the whole thing. If it keeps working, the case for phi as a genuine substrate gets stronger. 10. What a hard skeptic can fairly say now. We have just walked through 8 big gates. The instrument triangle. Can you measure a dimension without any hidden rhythm? Phase windows. Can you have clean laws and interference-like structure with no possible phase description? Lockstep deformation. Can you bend time, space, or motion alone with no coupled response? Cross-scale consistency. Is there a whole scale of reality that uses dimensions but bends waves? No orphan laws. Is there a core law that flatly refuses any phase translation? Coherence and noise. Can sharp patterns arise from proven phase chaos? Extra ingredients and mind. Does anything causally important live outside all possible phase structure? Phase-first predictions and edge regimes. Do phi-based predictions survive torture at the extremes? Each of these is, in spirit, a way of asking the universe, are you really built out of one continuous rhythm and its echoes, or are we forcing a metaphor too far? A hard skeptic, after hearing all this, does not have to like Holophase. They do not have to trust it. But they also cannot honestly say, this is just unfalsifiable metaphysics. It is all vibes with no way to be wrong. It never tells us what would count against it. Because now, you have a list of very concrete doors. If experiments walk through some of them, Holophase loses. If experiment keeps bouncing off them year after year, then at the very least, phase as substrate has earned the right to be taken seriously. 11. Where this leaves us as episode 5 closes. Across episode 5, you and I have questioned whether energy really is the deepest thing or just a clever tally of something deeper. Met phi, the holophase, as a candidate for that deeper thing, a single rhythm spanning scales. Reinterpreted time, space, and motion as dimensional echoes of phi's cadence, gradients, and flows. Walked from quantum flicker to cosmic drift, watching dimensions change character as different bands of phi dominate. Treated the laws of physics as grammar rules for phi's allowed changes. And now, we have written down a set of sharp tests, ways the world could simply say no to this entire story. In the final part of episode 5, we will step back and do something quieter. We will braid all of this together into a single human conclusion. We will ask what it would mean, scientifically and existentially, if a phase-first, dimensions as echoes model keeps surviving everything we throw at it. But even now, as you sit with these gates, you are doing something rare. You are not just hearing a grand vision of the universe. You are watching that vision offer its own execution list. Holophase might turn out to be wrong. It might turn out to be only partly right. Or it might turn out to be very close to how reality actually runs itself. What matters at this stage is that it behaves like a real hypothesis. It steps into the light. It tells you where to aim. And it promises not to flinch if the universe pulls the trigger. That, more than the poetry or the elegance, is what makes it worthy of your time. And if, in the years ahead, you see new experiments in timing, metrology, interference, extreme gravity, quantum foundations, or neuroscience, you will have a new question you can quietly ask yourself. Did that result make it easier or harder to tell the whole story in the language of a single phase field and its echoes? If the answer again and again is easier, then one day we may look back at moments like this as the time when a deeply strange idea stopped being just a story and started to look like the code of existence trying to recognize itself. And as you listen, remember, you are not just a spectator to this testing. Every time you ask a hard question, every time you doubt, every time you insist on a cleaner experiment or a sharper definition, you are helping decide whether phi is a genuine doorway into reality or just another beautiful detour. In that sense, the Holophase program is already doing its job. It is teaching us how to ask better questions of the world.